Hi, so today I'm going to introduce the following vocabulary words of the geology unit to you. I listed all of them here so you can see them. Now let's get started. First, let's look at the core. The definition of core is the ball-shaped center of Earth, lies beneath the cool brittle crust and the mostly solid mantle. So if you look at the diagram here, the Earth's core consists of the yellow part here, the inner core, and the orange part here, which is the outer core. And the inner core consists of solids and iron, and the outer core is mostly liquid. For enrichment, the Earth's inner core is surprisingly large, measuring 2,440 kilometers across. It makes up 19% of the Earth's total volume, which makes it just 30% smaller than the Moon. So the Earth's inner core is quite large. Now let's move on to the next word, the mantle. The mantle is a thick layer of less dense, elastic rock surrounding the core. So we just talked about the inner core here, the outer core here, and the mantle is just the orange part here surrounding the core. The mantle is divided into two zones, the upper mantle and the lower mantle. The upper mantle contains the lithosphere and the asthenosphere beneath the lithosphere, and I will talk about these two terms later. The crust. The crust is the thin, brittle, low-density layer of rock that covers Earth's surface. So the diagram here shows the crust is here at the surface of the Earth, just above the mantle. The crust consists of two parts, the oceanic crust and the continental crust. Due to available carbon, oxygen, hydrogen, water, and other life-forming elements, life exists only on Earth's crust, so the crust is the home for all species on Earth. Okay, so now let's move on to the asthenosphere. The asthenosphere is a portion of the upper mantle, contains especially soft rock, melted in some areas. So the diagram here, you can see that the mantle is here and the asthenosphere is here. So it locates on the upper mantle and it's underneath the lithosphere. For enrichment, the depth of the asthenosphere is different in some regions. It can reach 430 miles or 700 kilometers depth in some regions. Now the lithosphere is the harder rock above the asthenosphere. It includes both the uppermost mantle and the crust. So the same diagram here, you can see that the lithosphere consists of the uppermost mantle, the oceanic crust, and the continental crust. The lithosphere is the location where all earthquakes on Earth occur, because an earthquake occurs when tectonic plates shift or collide. If you wonder what plate tectonics is, let's talk about it. This term is extremely important in geology. It means the movement of lithospheric plates due to the movement of mantle material. So if you look at the diagram here, you can see the red lines and you can see many portions here. Each portion represents a plate on Earth. We have North American plate, Pacific plate, African plate, Eurasian plate, and so forth. And there are three types of boundaries between the tectonic plates. They are divergent, convergent, and transform boundaries. And now let's talk about them. First, the divergent plate boundaries. It is when tectonic plates push apart from one another as magma rises upward to the surface, creating new lithosphere as it cools. So the diagram here shows a divergent boundary, and you can see that two plates are moving apart from each other, and they're moving in opposite direction, and here is the magma that rises up onto the surface. One example of a divergent plate boundary is the Mid-Atlantic Ridge running through Iceland. And the second type of boundary is the transform plate boundaries. It is a place where two plates meet, slip, and grind alongside one another, creating friction that generates earthquakes along strike-slip faults. So the diagram here, we can see that a transform plate boundaries is when two plates meet and they slip each other, and they are moving in opposite direction. And the orange spot here represents the faults that caused by the transform plate boundaries. Examples of transform plate boundaries are the San Andreas Fault Zone of Western North America and Alpine Fault of New Zealand. The third type of boundaries is convergent plate boundaries. The definition of it is when two plates converge or come together, and it can give rise to different outcomes. And there are three types of convergent plate boundaries. The first is the oceanic continental boundaries. It is here. You can see that it happens when an oceanic crust and a continental crust collide. And the second type is oceanic-oceanic. It means when two oceanic plates collide. And the third type is continental-continental. It just means two continental crusts collide to each other. So in sum, convergent plate boundaries is when two plates converge and collide with each other. Subduction. The definition of subduction is the process in which the oceanic crust slides beneath continental crust. So if you look at the diagram here, when an oceanic crust collides with a continental crust, because the density of the oceanic crust is greater than the density of the continental crust, the oceanic crust slides beneath the continental crust. And this is the subduction zone. It's right here. Subduction zones happen near the Ring of Fire, which is offshore of Washington, Canada, Alaska, Russia, Japan, and Indonesia. Now let's look at continental collision. When two plates of continental lithosphere meet, the continental crust on both sides resists subduction and crushes together, bending, buckling, and deforming layers of rock from both plates. And if you look at the diagram here, a continental collision is when two continental crusts collide. And you can see that here's the mountain range. Mountain range is caused by continental collision. Portions of the accumulating masses of buckled crust are forced upward as they are pressed together, and mountain ranges result. We just talked about plate tectonics. We talked about the composition of Earth. Now let's talk about rocks. There are three total types of rocks on Earth. The first type is igneous rock. Igneous rock is the rock that forms when magma or lava cools. So you can find igneous rocks near volcanoes. And here's a picture of a type of igneous rock. Its name is basalt. And note that there are two types of igneous rocks, intrusive and extrusive. Intrusive igneous rocks are magma that cools slowly below Earth's surface, and extrusive igneous rocks erupt onto the surface, where they cool quickly to form small crystals. And the basalt is a common extrusive igneous rock. Okay, now let's talk about the second type of rock, which is the sedimentary rock. Sedimentary rock is rock that forms as sediments are physically pressed together and as dissolved minerals seep through sediments, and act as a kind of glue, binding sediment particles together. So here's a picture that shows a sedimentary rock, and being more specific, it is a sandstone. So the sediment here is sand. For enrichment, sedimentary rocks cover the majority of the Earth's rocky surface, but only make up a small percentage of the Earth's crust compared to metamorphic and igneous types of rocks. And here we have a new verb, which is metamorphic. And now let's look at it. It is the third type of rocks found on Earth. Metamorphic rock is any type of rock that is subjected to great heat or pressure. It may alter its form and it becomes metamorphic.